Okay, let's get started then. We're excited to have all of you join us today for this webinar. Our webinar today is presented by our senior software security engineer, Matt Schwartz, who will help us understand this Log4j exploit and how to detect and mitigate this. Before Matt gets started, I have a few housekeeping items. If you have any questions, please feel free to send them via chat. We'll have a Q&A at the end of this session. Matt, the floor is yours.
Yeah. Hi, I'm Matt. I was previously introduced. I'm the guy who's presenting. So if you're here today, you probably are already aware about the Log4 shell zero-day vulnerability, but this talk is going to go into more detail about the technical insides of it, as well as how to go through mitigation steps. So let's just start with an agenda. We're going to start with what is Log4 shell, the impact of it, not only on your software that you're writing and your dependencies, but also third-party services that you may be using, the technical insides of how this exploit works, and then last and most importantly, how to detect whether or not you are exposed to this Log4 shell vulnerability, and if so, the steps you can take to mitigate and protect your services from having this exploit be used. So let's start from the top. Log4 shell was discovered in the end of 2021, in the middle of December, and it was published by, or rather that's when it was published, and it was published by a member of Alibaba's cloud security team. What makes it so bad is that it allows for arbitrary remote code execution. So any attacker that's able to execute this attack can run any code they want on your servers and access anything that those servers have access to. What makes this particularly bad is just how easy it is to execute this attack. So that brings us to the question of what is Log4j? Well, Log4j is an open source logging framework that logs data within applications, and it is the vector through which this attack occurs. It happens to also be ubiquitously used in Java applications, especially in enterprise. Think your banks, cloud infrastructure, even down to Minecraft servers. It is everywhere, and it is prevalent to this degree because it's almost like the de facto logging standard within the industry. It is not unreasonable to expect that if you use Java at your company, you are likely exposed at least to having Log4j. So the way this vulnerability works is that when Log4j processes log messages, it takes in a string, and this string can contain variables. So think of it sort of like string interpolation and format strings for C, C++, where you have some type of stand-in where the value is then processed at runtime. If a user is able to input a malicious log message, Log4j then can go to a JNDI interface and execute the code that the malicious user wants to attack you with. So we'll get into what JNDI is in a slide or two ahead, but it's worth noting that this attack is executed through log messages. Again, it's arbitrary Java code on your servers. Now, the impact of this vulnerability is large. It's not limited solely to software that you write or dependencies that you use. If you are using a third-party service, think of Elasticsearch or Kafka, Spark, Flink, you are potentially exposed to this vulnerability. If one of your users can input some type of input that then gets passed over to Kafka, and then can be captured in a log message, your Kafka is exposing you to this remote code execution vulnerability. There is an open source effort to track all of these software as a service and software products that are potentially exposed to Log4 shell. You can find it at the link provided here, and all these slides will be available after the presentation. In this GitHub repo, it will include a list of all of the potential softwares, whether or not they're investigating if they're impacted, whether or not there is a fix or needs to be a fix, and if there are steps you can take to mitigate your exposure using that service. I would recommend consistently checking this if you're using any of the listed programs, because this is a active and dynamic situation that is changing over time, so it's worth staying up to date. So as mentioned before, what is JNDI and how does it actually allow the vulnerability to work? So JNDI is an acronym that stands for Java Naming and Directory Interface. And I've bolded interface very purposefully. It's not an implementation of anything. It's just a standard interface like any API will be. And it allows for simple lookups of a resource by name. Think of it like a DNS server where you send a URL and then get back a machine-readable IP address. And this makes this easy for us mere mortals to do these lookups. So for example, with a DNS server, you would provide youtube.com and get back a IP address for YouTube to access YouTube servers. Similarly, for JNDI, you would specify you're using the JNDI protocol to access some resource, and then you receive a resource reference. Now, what that resource reference can be isn't necessarily important here. It can be a reference to an object, serialized objects, maybe just some data with some attribute. It's just important to know that it will return whatever the resource points to. So LDAP is the implementation of the JNDI interface that allows for the malicious code to be injected. And it stands for Lightweight Directory Access Protocol. And think of it as a networked directory system where you can access entries within that network. It's sort of like a phone book where if you can run queries such as like find every single John and give me their phone numbers. Or you can say, I'm looking just for John Wick, just give me that guy's number, and that's it. So JNDI here acts as the interface through which LDAP is accessed for your Java applications. So the way this will work is you'll have your services running, you'll have your app running, it'll run a log, and then that log will say, hey, use JNDI interface to access a server running an LDAP protocol to return some resource. And everything's good, everything's fine, this is working as expected. However, just like with DNS, custom LDAP servers can be implemented, and you can provide a reference to your, or rather an attacker's, malicious LDAP server. So in the case where a malicious log message is able to be injected, the Log4J will then pull down the resource from the malicious server. Again, just using the JNDI interface on top of LDAP. So here we're going to be downloading just a payload object from the rce.server domain. So here's an example of a exploit using Log4j. Now in this case, it's hard-coded, but you'll see it's using the JNDI interface to hit an LDAP protocols or a server implementing LDAP at malicious.server, and then it's going to download malicious class. So in this case, for this exploit, Java classes that are compiled are what is returned by the LDAP server, and then that compiled class is run in the JVM runtime when it is pulled in. So now I'm going to switch over to a demo where I'm going to actually go into demonstrating this vulnerability and one of the example mitigation steps. If you give me a moment, I'm going to share my screen. All right, so over here, we are in IntelliJ, and there are two files or two classes that are worth mentioning here, and open already is think of it as your services that are running and making logs. Now, this example is a bit contrived. You're not obviously going to be running just hard-coded strings through your logs. However, it's not unreasonable to say that you might log a user name, user email, user agent header coming in for every request. And these are things that users sending those requests can control. So if I just set my user agent to look like this, and you log user agents, and you're using Log4j, you're going to end up actually executing this remote code execution exploit. So there is an LDAP server that's implemented locally. The innards of it don't matter. It's just worth mentioning that it will provide the malicious class that has already been compiled, and I will show you that right after. So we're going to start by spinning up the LDAP server. And we see that it's turned on and listening on localhost quad 9. And let's see what malicious attack we're going to be executing. So we're going to be taking 2 actions. First, we're going to be opening FOSSA.com in Google Chrome. And then we're going to use the native dialog alert box to Mac OS to print that I have been pwned. So we can start by running this log exploit, which is just hitting, running this main file here. It will also compile this malicious class, and then the LDAP server knows to pull in this class file. So let's run the exploit and see what happens. And as you notice, we are now in Chrome, and there is a native dialog box saying that I've been pwned. Ha 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 ha. The purpose of opening up in Chrome and using a native dialog box is just to reinforce that this is a very bad vulnerability. It is able to access anything that your server has access to. In this case, it's my local machine, so any sensitive information on my machine could be exposed. Now, there is a way to execute a fix here, but before we get to that, I want to point out the Java runtime interpolation here. You'll notice that in the log messages that are sent, we obviously didn't print the raw string for the Java runtime, but we did print the raw string for the RCE execution. This is because the string just stayed as a string here, but Log4j knows that a structure like Java :runtime here is a variable with a value that can be interpolated. So it injects the value into your logs. This isn't necessarily a vulnerability because the log should still be under your control, but a prudent and malicious internal actor may be able to inject something that exposes a database password that then gets dumped into logs so that they can then have access to a password in a database that they didn't previously. So there's some internal infosec here, but the real concern is the remote code execution vulnerability. So this is running without any mitigation efforts being used. There is a way to, without upgrading, protect you from this vulnerability. So you can pass the following configuration argument to your VM. That's just log4j2 format message no lookups equal to true. And this just tells log4j, hey, let's not try to run these format strings and do these lookups. Just print what you get and avoid this altogether. So we're going to test this out again, and what we should expect to see is that we're not getting an interpolated value here. We should just see Java :runtime. So let's run this. And exactly as expected, you get Java :runtime because the value is not being interpolated, and while the attempted attack is still printed, Chrome didn't open, didn't get an alert box. This successfully mitigated the underlying issue. So returning back to the presentation. So we've gone over just how bad this vulnerability can be and demonstrated it in a controlled environment. The next question that you may have is, how do I know if I or any of my services are exposed to Log4Shell? And the way to do that is to scan your dependencies to see if you are using Log4j, specifically one of the vulnerable versions, which we'll go into detail about in the next slide. The way to do this is 2 steps. You will be downloading FOSSA CLI, which is our open source tool for determining your dependency graph, and then download JQ, which is an open source tool for formatting and querying JSON objects. So what you're going to run is FOSSA analyze-o. What normally happens when you use FOSSA analyze is it will build a dependency graph and send that to our servers. But because this is such a bad vulnerability, we want to make sure that you can run this analysis without even having an account with FOSSA. So -o prints out the dependency graph as JSON to the terminal. If you pipe that to JQ, you get nice formatting for that JSON, and then you can search for log4j core, which is the vulnerable package. It is worth mentioning that later today, we are going to have a dedicated command for detecting Log4j and vulnerable versions within your software. You will be able to do this by going to FOSSA CLI and downloading. If you do it now, you'll just have to upgrade. It comes with the script. And all you'll need to do is run FOSSA Log4j, and it will determine if you are using Log4j in a vulnerable version, and it will tell you how you get to that vulnerability. You do not need an account for any of this, and I want to stress that. This isn't really a sales pitch here. We're trying to make sure the world is safe. So after you've determined if you are actually exposed to the Log4Shell vulnerability, the next steps you need to take is to mitigate your exposure to it. The original vulnerability came out in 2.14. However, it was fixed in 2.15. That fix didn't. It fixed the initial issue with the Log4Shell. However, there were some workarounds, and it introduced a potential denial of a service attack, DOS vulnerability. Relative to RCE, it's not as bad, but it's still bad. So another patch for that was put out for 2.16, which also had another vulnerability introduced. And this is why we are recommending that you upgrade to 2.17, which is the next safest version that we are currently aware of. It's worth mentioning that if you are listening to this webinar in the future, this is a dynamic situation that's constantly being updated. So we will have a link for our blog later in the slide deck. Please use that to keep up to date for the most recent steps you need to take to mitigate this. If you're on Log4j 2.10, you're going to have, or 2.10 or above, you're going to have different steps to take to protect yourself than you would if you were on 2.0 or through 2.10. So as mentioned in the demonstration earlier, you can just set Log4j2 format message no lookup set to true, and that will protect you from having the interpolated values be executed. If you're on 2.0 to 2.10, there's extra steps you need to take to remove LDAP from actually being accessed at runtime, and then also prevent any interpolation of values. There are other ways that you can help protect yourself, but because we're trying to use this as a quick and terse way of communicating mitigation steps and mitigation steps at work, you can check out our blog for these details. We're not presenting them here because they will work in some cases, but a dedicated attacker will reasonably find a way around these options. So, for example, setting up WAF or egress policy restrictions for your network are ways to protect yourself. But again, it isn't a full stopgap effort. You need to upgrade, and we recommend doing so as quickly and early as possible. So that is Log4Shell in a nutshell. So now I am more than happy to take questions, so please do submit them through BrightTalk. And we'll just wait here for a bit.
We have a question, Matt. This one is, what is the denial of service vulnerability I heard of earlier this weekend? Should I worry about it?
Yeah, the denial of service vulnerability, as mentioned before, it was introduced in the effort to patch the existing Log4Shell vulnerability. It isn't necessary. It's a bad vulnerability that can potentially take down your services, but it won't expose you to malicious code being executed on your servers. It's not, if you're already in the process of running an upgrade, it really shouldn't be a concern. You should just be moving straight to the next safe version.
Okay, got it. The other question is, if I upgrade Log4j to 2.17, will that break my older apps?
So whether or not it breaks your older apps is going to be very dependent on your environment. If you rely on JNDI to get certain log messages, and you process those log messages in a special way, you're not going to get the same log messages as you did before. But I would imagine if the code compiles, you're likely going to just be dealing with just malformed or unexpected log messages.
How did something this bad happen, and just how serious is this vulnerability? Those are the next two questions.
Yeah, so this happens and I don't want to really point blame at anyone here, because at the end of the day, we're all software engineers. We're not perfect. We're human. But Log4j was written by two unpaid open source software engineers, and we're asking the world of them to immediately go and fix this. It's not to say that paying them would have fixed this underlying issue, but having actual resources sent to them to make sure that this basically standard for enterprise service software package had better comprehensive testing, like input fuzzing, that could have potentially found this vulnerability. And I believe the other question was just how
serious, yeah.
Yeah, so to use a kind of hyperbolic reference, I kind of think of this as think Lehman Brothers, September 2008, or Ever Given in the Suez Canal in last year, or even like Evergrande in China and their default cycle. In all of these cases, it was a very, very bad issue that had cascading effects throughout the ecosystem. It crippled the services and the ability for companies to function, and downstream actors were impacted. So if you're using a service like Elasticsearch for certain versions that use Log4j under the hood, you can be exposed even without knowing it. And that's why I like this analogy, because there really are cascading effects. And it's not just limited to the dependencies you're very aware of. It also includes the dependencies that your dependencies are using. These are known as transitive dependencies. And very often developers are not aware of the transitive dependencies or the versions that these transitive dependencies have.
Okay. The next question is, how do I get my organization to update quickly?
Yeah, so this one's a bit tougher. At the end of the day, to update quickly, you need to have access to and be able to convince decision makers at your company. So while you might be inclined to go to your manager, and that might be the right path to go, that might not be where to stop. So the first step I would take is determine who the right person to get this information to is in order to get a speedy response. Next is to determine whether or not, next is to prove to them just how bad this can be. So if you are a fairly technical shop, or you have a good relationship with these individuals, you may be able to just reach out to them directly and explain to them over a message. However, if there's a lot of middlemen, or there isn't a trusting relationship built yet, it may help for you to demonstrate execution of this vulnerability. And there are a ton of resources that we have that are available on the internet for this. I can also post a reference to the source code after the presentation, just so that you can see if there are holes in your existing infrastructure. But I generally, for something like this, the fastest way to convince someone is to show in some staging environment, hey, I just deleted all of our data, and this is totally doable in production.
Okay. How will we know when the CLI updates are ready?
Yeah, so if you've signed up for this webinar, which I believe you have because you are here, we'll send out a link to the CLI updates via email. If you're watching this in the future, first of all, hello. Second of all, you can just pop over to our CLI repo, and it should already be integrated by default.
Okay. The other question is, would you please share the link? I am not sure what this points to, so if you can clarify which link you're talking about, we will be more than happy to share the link. The next question is, will this be available to use later?
What is this here? The presentation?
The presentation will be available. Yes, I'm assuming the CLI tool that would be available too.
With the CLI tool will be available later today.
Okay.
We're just finishing things up. We really want to make sure we don't have false positives or false negatives coming out. So we're just shoring up our due diligence on our side.
Okay. The next question is, can you provide a list of applications that are vulnerable?
Yes. So earlier in the presentation, there was a link to a GitHub repo with the list of vulnerable applications. We can actually let's also send out that link in an email, just because it's that important to make sure everyone listening has. But the slides will be available after the webinar. You can always go back and reference them.
Okay. The next question is there a way for an external bad actor to exploit this vulnerability, or is this vulnerability more likely to be an internal InfoSec threat?
Yeah, I mean, right off the bat, it's going to be easier to determine how to act on this if you have access to the code and like, all right, I see we're logging here in this way. That being said, it's pretty reasonable to expect that an external actor could access this vulnerability, especially if you're logging standard fields like username, user agent, etc. on every request. While the threat internally is easier, there's already been productionized automated versions of this attack scanning the internet, trying to inject malware such as ransomware or just backdoors into your servers. So while the actual exploit risk is slightly higher internal, you have the pressure of the whole world now trying to find every exploit that's still available before the patch.
Okay, I think the last question, which was like they had asked for a link, they said the last link. Well, we'll be sharing the slides with you, so I think the link will be available to you once the webinar is finished. Any more questions? I think this is the last of it. We will give the audience 5 more minutes to see if they have any other questions before we end this chat.
So before we end here, just know that we're very appreciative that you came to this webinar. Our main concern is just to make sure that you and your services are safe. You can always email sales@fossa.com if you want to have automated detection of this of any open source vulnerabilities that you may be exposed to. This is a service we offer on every new change to your code. Don't hesitate to reach out if you're interested or have extra questions.
Yes, we'll be sending out, as I mentioned, this slide deck and also the link to the CLI when it's ready. So I think this is it for this talk today. We will conclude now. Thank you for everyone who attended, and thank you, Matt, for doing this. Bye.